Hello, so in this video I wanted to talk a little bit about this really basic neural network that I made and kind of the process of how I made it and some of the logic that goes into it. So my initial plan going into this was to make some big complicated neural network, maybe something that could, recognize digits that someone drew or like tell whether there's a cat in a picture you input. Um, but I kind of ran into a few problems and I realized that all that stuff is really, really complicated and you need a lot of linear algebra and like really complicated math to be able to do that. Um, so what I ended up with was something really, really simple. It basically takes in some input data, and in my example, you can imagine it as like looking at some animal, and then you're looking at its width and height, and then you're identifying whether it belongs to species 0 or species 1. And then I'll go into MS Paint and show you a little bit about how it works. So this is basically the most basic version of a neural network you can have. It has two inputs that get passed into an activation function and then give you an output. So I'm kind of oversimplifying it a little, but basically the input can either be 0 or 1, and then it's going to be multiplied by a certain weight, and then the sum of these are going to be passed into the activation function. And it's okay if that doesn't make sense, it's just kind of a basic overview. And there's also a bias that gets added into it, so basically just like, you can just think of this as another number that's being added, basically what will be put into here if both of the inputs are 0. That probably doesn't make a ton of sense right now, but hopefully it will in a minute. And then in terms of this activation function, if I go into a graphing calculator, this is the actual function. It's 1 over 1 plus e to the negative x. And basically what it does is it squishes all of its inputs to be between 0 and 1. Okay, so the number you might put in for x could be like anything really. And like I said, it'll be the sum of the inputs times their respective weights plus the bias, if that makes sense. And then you want that to be constrained between 0 and 1. And basically you're saying if the output is near 1, then in my example, it'll be species 1. And if the output is near 0, then it'll be species 0. So yeah, this function just kind of constrains everything to be between 0 and 1. Now if I go into the code itself, so these are the inputs. So in this example, the first set of training data has a width of 1 and a height of 1, and its species is 0. The second one has a width of 2, a height of 1, and its species is 0. And if you go down here, this one has a width of 3, a height of 1.5, and its species 1. So if you look at this data for a minute, you might notice that basically some of the smaller animals turn out to be species 0, and some of the bigger ones turn out to be species 1. So if we put in this input data, what we're looking for is that the neural network will learn to realize like what we can see, and then if we pass in a new set of data that the program has never seen before, it should be able to tell us whether it's likely to be species 0 or species 1. Okay, so this is kind of just the setup for everything. So this is kind of what I was talking about before with the weights. So if you remember, the weights are what the input gets multiplied by before it gets passed into that activation function. So when we start, the weights are all randomized, okay? And then once we start training, we look at a specific piece of the input data, and then we call the predict function on this piece of data and this piece of data in each set, if that makes sense. And then in the predict function, basically it multiplies that input by the first weight and adds that to the second input multiplied by the second weight, and then it adds the bias. Okay, it takes that number and then puts it into the activation function, which is 1 over 1 plus e to the negative x. So hopefully that all makes sense. And then basically its prediction is whatever number that spits out. So that'll be any number between 0 and 1. And then the good thing about the neural network is that it actually learns to kind of refine its prediction on its own after you pass in a lot of data. And this part gets a lot more complicated. It kind of involves a little bit of linear algebra, but basically it looks at the slope of the function, and it's basically trying to find the point where the cost is at a minimum. And the cost is basically how wrong the neural network is. So it just does all this math, and it adjusts the weight and the bias, and then eventually the neural network becomes more accurate. Okay, so hopefully that makes some sort of sense. It's okay if it doesn't. And then this is the end of it. It just makes the neural network. And then if I run it, you can see here. So this is before any of the training. So we inputted these 3 new pieces of data. So for example, a species with, with width 4.5 and height 1. And then the neural network outputs 0.21. So if you remember, if it outputs 0, it thinks it's species 0. And if it outputs 1, it thinks it's species 1. So before any training with just random weights and everything, it's not really sure what species this is. It just kind of basically gives us a random output. But then after we train, based on our training data up here, 1,000 times, and then pass in the same data that the network has never seen before, it gives us 0.98, which is very close to 1. And this should be species 1 because it's pretty big, which is good. And then if we give in 1 and 0.5, it gives us a number close to 0, which makes sense because this is small enough to be species 0. And this is another one that's pretty small. It should be classified as species 0, and if you look, it is. And yep, so that's basically everything. It's just a really basic neural network that can learn to classify the species of a data based only on this training data. And it basically just goes through and adjusts the weights and biases like 1,000 times, and then over time it can learn to become more accurate. And yeah, that's everything I wanted to talk about. Thanks for watching.